If the Earth's core were to stop spinning and reset itself, the consequences would be catastrophic and far-reaching, affecting both the planet and its inhabitants. Here is a detailed breakdown of what might happen. 1. The Earth's magnetic field collapses. The Earth's outer core is composed of molten iron and nickel, and its movement generates the planet's magnetic field through a process called the geodynamic. If the core stops spinning, the magnetic field would weaken and potentially disappear. Without a magnetic field, the Earth would be exposed to harmful solar radiation and cosmic rays, which could strip away the atmosphere over time and increase radiation levels on the surface, harming life. 2. Atmospheric loss. The magnetic field protects the atmosphere from being eroded by the solar wind. Without it, the atmosphere could gradually dissipate into space, leading to a dramatic drop in air pressure and the loss of oxygen, nitrogen, and other gases essential for life. This would make the surface uninhabitable for humans and most other forms of complex life. 3. Changes in gravitational force. The Earth's rotation and the movement of its core contribute to the planet's overall gravitational field. If the core stops spinning, there could be slight changes in gravity, though these would likely be minor compared to other effects. However, the redistribution of mass in the core could lead to earthquakes and volcanic activity as the planet adjusts. 4. Extreme geological activity. The sudden stoppage of the core could cause massive earthquakes and volcanic eruptions as the Earth's crust adjusts to the change in internal dynamics. This could trigger tsunamis, landslides, and other natural disasters, leading to widespread destruction. 5. Climate disruptions. The Earth's magnetic field and core rotation play a role in stabilizing the climate. Without a functioning core, weather patterns could become erratic, leading to extreme temperatures, storms, and other unpredictable climate events. 6. Impact on life. Humans and animals. Increased radiation exposure would lead to higher rates of cancer and genetic mutations. The loss of atmosphere would make breathing impossible unless technology provided artificial life support. Plants. Photosynthesis would be disrupted by the lack of a stable atmosphere and increased radiation, leading to the collapse of ecosystems. Microbial life. Some extremophiles might survive, but most life forms would perish. 7. Long-term effects. Over time, the Earth could become a barren, lifeless planet like Mars, which lost its magnetic field and most of its atmosphere billions of years ago. If the core were to reset and resume spinning, it might take millions of years for the magnetic field and atmosphere to stabilize, if at all. What would happen during the reset? If the core were to stop spinning and then restart, the transition period would involve massive geological upheaval, extreme climate changes, and widespread destruction. The process could take centuries or millennia, during which life on Earth would struggle to survive. Humans might need to rely on advanced technology, such as underground habitats or space colonies, to endure the catastrophic changes. In summary, the stoppage and reset of the Earth's core would be an unprecedented event with devastating consequences for the planet and all life on it. The loss of the magnetic field, atmosphere, and stable environment would render Earth uninhabitable for most life forms, and the recovery, if possible, would take an unimaginably long time. 1. The core's role in Earth's dynamics. The Earth's core consists of two parts: inner core, a solid sphere of iron and nickel; outer core, a molten layer of iron and nickel that flows and generates the planet's magnetic field through geodynamic action. The core's rotation is driven by convection currents, heat-driven circulation, and the Coriolis effect, Earth's rotation. If the core stops spinning, the following chain of events unfolds. 2. Magnetic field collapse. The magnetic field, generated by the motion of the outer core, acts as a shield against solar wind, a stream of charged particles from the sun, and cosmic rays, high-energy particles from space. Without the magnetic field, solar wind would begin stripping away the ionosphere, upper atmosphere, weakening the atmosphere's grip on Earth. Over time, this would lead to the escape of atmospheric gases into space, particularly lighter elements like hydrogen and helium, eventually depleting oxygen and nitrogen. 3. Atmospheric breakdown. The loss of the magnetic field would expose the surface to harmful ultraviolet (UV) radiation and cosmic rays, increasing the risk of cancer and genetic mutations in living organisms. Atmospheric pressure would drop dramatically, making it difficult for liquid water to remain stable on the surface. Oceans would begin to boil and evaporate at lower temperatures. The greenhouse effect would weaken, leading to extreme temperature fluctuations, scorching heat during the day and freezing cold at night. 4. Geological upheaval. The Earth's crust and mantle are influenced by the core's dynamics. A sudden stop in core rotation would disrupt the plate tectonic system. Earthquakes, massive seismic activity would occur as the crust adjusts to the new internal equilibrium. Volcanic eruptions. Increased pressure in the mantle could trigger volcanic eruptions on an unprecedented scale, releasing ash and gases that further disrupt the atmosphere. Tsunamis. Undersea earthquakes could generate massive tsunamis, devastating coastal regions. 5. Climate catastrophe. The collapse of the magnetic field and atmospheric erosion would destabilize weather patterns. Extreme storms, intense storms and hurricanes could form due to the imbalance of heat distribution. Global cooling or warming, depending on the timing. Volcanic ash could block sunlight, causing a volcanic winter, or greenhouse gases could trap heat, leading to runaway warming. Desertification. Ecosystems would collapse, leading to widespread desertification and loss of agricultural land. 6. Impact on life. Humans. Without a stable atmosphere, humans would require sealed environments or spacesuits to survive. The increased radiation would lead to higher mortality rates and genetic damage. Animals and plants. Most species would go extinct due to radiation, lack of oxygen, and extreme climate conditions. Only extremophiles, organisms adapted to harsh environments, might survive. Microbial life. Some bacteria and archaea in deep oceans or underground might persist, but biodiversity would plummet. 7. The reset process. If the core were to stop and then begin spinning again, the process would involve reactivation of the geodynamic. The core would need to regain its convective motion, driven by residual heat and radioactive decay. Gradual recovery of the magnetic field. The magnetic field would take millennia to rebuild, assuming the core's dynamics stabilize. Atmospheric regeneration. If Earth retained enough water and gases, atmospheric pressure might eventually recover, but this would depend on the extent of initial loss. 8. Long-term scenarios. Mars-like future. Earth could resemble Mars, with a thin atmosphere, no liquid water, and a barren surface. Life would be confined to isolated pockets. Partial recovery. If the core resumes spinning and the magnetic field regenerates, Earth might stabilize over millions of years, allowing life to re-emerge under new conditions. Human adaptation. If humans survive, they will rely on advanced technology, such as underground cities, space habitats, or terraforming efforts to sustain life. 9. Scientific implications. Planetary dynamics. This event would provide insights into the importance of a planet's core in maintaining a habitable environment. Exoplanet studies. Understanding Earth's core dynamics could help scientists assess the habitability of other planets. Geological processes. The event would offer a unique opportunity to study the interplay between the core, mantle, and crust. Upon the reset on the Earth's core, humanity will have to endure several measures to endure and overcome the chaos and hazardous condition to survive the everlasting rough climate, starting with 1. Immediate survival measures. Radiation protection scenario. Underground habitats. Humans would need to construct vast underground cities shielded from radiation. These habitats would require life support systems, including air purification, water recycling, and controlled environments for agriculture. Radiation shielding. Materials like lead, concrete, and boron would be used to protect structures and inhabitants from cosmic rays and UV radiation. Protective suits. For any surface activity, advanced radiation-proof suits would be necessary. Atmospheric preservation scenario. Artificial atmospheres. Sealed environments would need to maintain oxygen levels and pressure. Technologies like oxygen generators and CO2 scrubbers would be essential. Atmospheric maintenance, efforts to slow atmospheric loss, such as geoengineering projects to release gases or create artificial magnetic fields, might be attempted. 2. Food and water security agriculture scenario hydroponics and aeroponics. Soil-based farming would be impractical, so humans would rely on indoor, soil-less farming systems. Artificial lighting, LED lights tailored for plant growth would replace sunlight in underground or sealed environments. Genetically engineered crops. Crops would need to be modified for higher yields, radiation resistance, and adaptability to artificial conditions. Water supply scenario desalination and water recycling. Seawater and wastewater would be treated and reused to ensure a sustainable water supply. Ice mining. If polar ice caps remain intact, they could be tapped as a water source. 3. Biodiversity preservation gene banks and cryopreservation scenario Svalbard Global Seed Vault. Existing seed banks would be expanded to preserve plant species. Frozen zoos, animal embryos, eggs, and DNA would be stored in cryogenic facilities to prevent extinction. Microbe preservation. Essential microorganisms for ecosystems and agriculture would also need to be preserved. Artificial habitats scenario biospheres. Large, self-sustaining ecosystems would need to be created to house animals, insects, and plants. Aquatic preserves. Marine life would require sealed, artificial oceans with controlled salinity, temperature, and oxygen levels. 4. Energy and technology energy sources scenario nuclear power. Fission reactors would provide a reliable energy source for underground and sealed environments. Geothermal energy. Heat from the Earth's interior could be tapped for power. Solar power. If conditions allow, solar panels could still be used on the surface. Advanced technology scenario AI and automation. Robots and AI would be essential for maintaining infrastructure, agriculture, and research. Space-based solutions. Satellites could monitor Earth's conditions and assist in communication and logistics. 5. Societal and psychological adaptation global cooperation scenario unified leadership. Governments and organizations would need to work together to allocate resources and manage survival efforts. Resource allocation, strict rationing and distribution systems would be necessary to ensure fairness. Mental health scenario support systems. Psychological counseling and community building activities would help people cope with the stress and trauma of living in confined, high-pressure environments. 6. Long-term strategies terraforming Earth scenario artificial magnetic fields. Scientists might attempt to create artificial magnetic shields using superconducting coils or other technologies. Atmospheric restoration. Over millennia, efforts could be made to rebuild the atmosphere by releasing gases from Earth's interior or importing them from other planets. Space colonization scenario Mars or moon colonies. Permanent settlements on other celestial bodies could serve as a backup for humanity. Generation ships. Large spacecraft designed for long-term habitation could carry humans and other life forms to distant star systems. 7. Steps to save sea life artificial ocean scenario sealed marine habitats. Large, controlled environments would be needed to preserve aquatic ecosystems, including reefs, plankton, and larger marine animals. Water quality management. Advanced filtration and oxygenation systems would maintain the health of these artificial oceans. Cold storage for marine species scenario cryogenic preservation of marine organisms like fish eggs, coral larvae, and essential microbes could ensure their survival. 8. Challenges and limitation scale. The effort required to preserve even a fraction of Earth's biodiversity would be immense. Time. Many species might go extinct before habitats and technologies could be developed. Sustainability. Maintaining artificial environments over centuries or millennia would require ongoing innovation and resource management. Fast forward to the future centuries later, a new beginning scenario the Earth had become a vastly different place. The surface, once teeming with life, was now a barren wasteland, scarred by endless deserts, frozen plains, and jagged mountains. The atmosphere, thin and fragile, shimmered faintly under the light of a pale sun. The magnetic field, though still weak, had begun to regenerate as the core slowly resumed its spin. Humanity, meanwhile, had endured, not on the surface, but deep below it. The underground network scenario. For centuries, humanity had lived in vast subterranean cities, interconnected by tunnels that spanned continents. These cities were marvels of engineering, powered by nuclear and geothermal energy, and sustained by advanced hydroponic farms and artificial ecosystems. The population was smaller, but resilient, and every resource was carefully managed to ensure survival. Scientists and engineers worked tirelessly to monitor the core's activity, using seismic sensors and supercomputers to track its progress. The first signs of recovery had come decades earlier, faint ripples in the magnetic field, detected by satellites orbiting the dead surface. It was a glimmer of hope, but no one dared to rush to the surface just yet. The biosphere preserve scenario. Underground, humanity had managed to preserve much of Earth's biodiversity. Massive biosphere preserves housed animals, insects, and plants, carefully curated to maintain ecological balance. Artificial oceans, sealed in domed caverns, teemed with marine life, from coral reefs to deep-sea creatures. Cryogenic vaults stored the genetic material of species that could not yet be reintroduced. Children in the underground cities grew up learning about Earth's past, its forests, oceans, and skies through holographic simulations. The stories of a world where life flourished under open skies became legends, fueling the collective dream of one day returning to the surface. The first steps back scenario. One day, a team of explorers ventured to the surface for the first time in generations. Clad in radiation-resistant suits, they emerged onto a stark, alien landscape. The air was thin but breathable, and the magnetic field, though weak, provided some protection from solar radiation. They planted hardy, genetically engineered plants in the soil, testing its viability. Over the years, these experiments yielded small patches of green, the first signs of life on the surface in centuries. Slowly, oxygen levels began to rise, and the atmosphere started to stabilize. A new Earth scenario. As the core's rotation strengthened and the magnetic field regained its strength, humanity began its long journey back to the surface. Massive terraforming projects were launched, using algae, bacteria, and engineered plants to rebuild the atmosphere and soil. Solar panels and wind turbines dotted the landscape, harnessing energy to fuel the effort. Animals were reintroduced to the surface, one species at a time, carefully monitored to ensure their survival. Insects, essential for pollination, flourished in the new ecosystems. Fish and marine life were released into oceans that had begun to recover, thanks to decades of purification and oxygenation efforts. A lesson learned scenario. Humanity had learned a hard lesson about the fragility of their home. On the surface, they built a new civilization, one that prioritized sustainability, harmony with nature, and the preservation of life. The scars of the past served as a reminder of their responsibility to protect the planet. As the core completed its reset, and the magnetic field fully stabilized, Earth began to resemble its former self. Forests grew, rivers flowed, and the skies turned blue once more. Humanity, having come so close to extinction, now thrived on the surface again, united by a shared purpose: to ensure that such a catastrophe would never happen again. The final scene scenario. On a warm, sunny day, a child stood at the edge of a forest, watching as birds flew overhead for the first time in centuries. The air smelled of earth and flowers, and the hum of life filled the world. The child turned to their parent and asked, "What will we do now?" The parent smiled and replied, "We'll make sure this never ends." And so, Earth's story continued, not as it had before, but as it could be, a testament to the resilience of life and the ingenuity of humanity. The core's reset had been a turning point, not just for the planet, but for those who called it home. Together, they had faced the unimaginable and emerged stronger, ready to forge a new future. Thanks for watching this video. If you enjoyed it, please be sure to hit that subscribe button to our channel and hit the bell for the next video to release so you can get a reminder. And if you feel even more generous, Be sure to give it a share, a thumbs up, and a comment. We look forward to seeing you on the next